You expect a steel beam to just, well, stay exactly where you put it.
Right, yeah, you really do.
Like when engineers design a suspension bridge or, I don't know, a skyscraper, there is this expectation of total, uncompromising control.
Absolutely. The blueprint is basically absolute law.
Exactly. The concrete doesn't just suddenly decide it wants to grow sideways to get a better view of the sun. The materials, they either hold the weight or they fail.
Yeah, it's a very binary thing.
It's clean, it's mathematical, and honestly, it's very comforting for us.
It is. We rely on our constructed environments to obey our instructions without question. But, step out of the city and into a garden, and that expectation of passive obedience just totally vanishes.
Oh, completely.
You step into the world of botany, and suddenly you are no longer dictating the terms. You are negotiating with a living organism.
Right, a living thing with its own agenda.
Exactly. Its own evolutionary programming and its own completely different set of architectural rules.
And that structural tug-of-war is exactly what we are unpacking for you today on this deep dive. We're looking at what I'd call a masterclass in the friction between human control and biological chaos.
Yes, and it's found in a really deeply personal source, too.
It is. We aren't dissecting some sweeping, dry scientific journal today. We are peering into the meticulous, everyday dedication of a gardener's diary.
Which is fascinating in its own right.
Right. Specifically, we're looking at a post from August 2nd, 2026. It's by a gardener named Ang, and it's titled Notes on Gardening. And get this, it is part 974.
Which is just wild, 974 consecutive entries. That implies a really profound long-term relationship with the soil.
Yeah, you don't just stumble into almost 1,000 entries.
No, you don't. It tells you immediately that this isn't someone casually throwing seeds in the dirt and just, hoping for the best. This is someone who observes the minute daily struggles of living things.
Okay, let's unpack this, because in this specific entry, Ang is battling a very specific botanical dilemma. We are looking at the unruly growth habits of the Mexican mint.
Also known as plectranthus-amboinicus.
Right. And Ang has a few pots of this stuff, including both the original and the variegated varieties.
Yeah.
And regardless of the variety, Ang is facing this universal problem with the species. It just has this relentless tendency to stretch and sprawl all over the place.
What's fascinating here is that the Mexican mint is somewhat caught between identities.
What do you mean?
Well, it had this growth habit where it really wants to trail and branch out. It almost wants to spread like a vine.
Okay.
But it doesn't actually possess the slender, lightweight anatomy of a true vine. The notes specifically highlight that the Mexican mint boasts these thick stems and really large, moisture-dense leaves.
So it's heavy.
Very heavy.
It's trying to build a tall, sprawling structure using completely the wrong materials. It's like trying to build a tall radio tower out of water balloons instead of steel scaffolding.
That is a perfect analogy, actually. Water balloons.
Right. Because it's turgid, it's full of water, and it's just heavy. It's constantly pushing outward and upward, trying to capture more light, and just piling on these heavy, fleshy leaves.
And eventually, it hits a physical tipping point. The sheer mass of the plant just overcomes its own structural integrity.
Gravity basically takes over.
Gravity always wins that battle.
Yeah.
When the stems reach a critical length, they simply bend and cascade outward.
They just collapse.
Yeah, the structural collapse is inevitable. The plant's biological ambition essentially outpaces its physical engineering.
And observes this collapse and notes something that's almost, tragic.
Yeah.
After the stems bow out and fall to the ground, the very tips of the plant are left, as Ang says, struggling to grow upward.
Yeah. The main stem has failed. It's lying totally horizontally. But that little tip is still fighting. It's curling back up toward the sun.
Which really makes you wonder, how does the plant even know it has fallen over? I mean, it doesn't have eyes. It can't see the ground. How does that fallen tip sense which way is up?
That is due to a really remarkable piece of biological engineering called gravitropism.
Gravitropism?
Yes. Yeah. And it all comes down to these tiny, dense structures inside the plant cells called statoliths.
Statoliths?
Yeah. Imagine microscopic pebbles inside a jar. These statoliths are heavy, starch-filled organelles. So when the plant stem falls over, gravity naturally pulls those statoliths down to the new bottom of the cell.
Wait, so they literally roll down to the lowest point of the cell wall?
They do. They physically settle at the lowest point, and when those heavy starch grains settle there, they trigger this massive chemical cascade.
Wow.
Yeah, they cause growth hormones to pool on the underside of that fallen stem.
Okay, I think I see where this is going.
Right, so that accumulation of hormones causes the cells on the bottom side to elongate much faster than the cells on the top side.
Ah, so the bottom stretches out.
Exactly. This uneven growth literally forces the tip of the stem to curve upward, bending it back toward the sky. The plant is constantly feeling for gravity and adjusting its architecture.
That is incredible. But, for Aang, the gardener, this miraculous display of gravitropism isn't celebrated at all.
Not at all.
No, it's seen as an aesthetic failure. Aang notes very clearly that this bending and sprawling creates foliage that is, quote, less aesthetically appealing.
Right, because the human ideal for this windowsill plant is this tight, compact, bushy shape.
Exactly. We want a neat little sphere of green. But the plant's natural gravity-bound reality is just messy and sprawling.
The conflict is so clear here. How do you force a fleshy plant that inherently wants to stretch and sprawl into a neat, compact sphere?
Right. You can't just build a tiny mechanical support system for every single leaf.
No, you can't. So you have to intercept its biological programming.
Which brings us to the gardener's main weapon,
Yeah.
pruning. Aang regularly harvests and cuts back the long stems. But from the notes, it's clear this isn't just a mechanical haircut. It's not just making a tall thing shorter.
No, not at all. You are stepping right into the microscopic, invisible world of plant hormones. When Aang snips off the very tip of that Mexican mint, it triggers a massive chemical shift inside the plant's vascular system.
Okay, walk us through that. What happens when the scissors snip the tip?
Well, you are intentionally disrupting a phenomenon known as apical dominance.
Apical dominance.
The topmost bud of a plant, the apical bud, is basically the control center for vertical growth. It produces a really powerful hormone called auxin.
Auxin. Got it.
So this auxin travels downward through the stem, and his primary job is to actively suppress the growth of all the other little buds lower down on the sides of the stem.
The side buds.
Yes, the lateral buds.
So the plant is basically running a chemical monopoly.
That's a great way to put it.
The top bud is just hoarding all the upward momentum. Let's imagine the Mexican mint's vascular system as a bustling highway network. Okay.
Okay, I like this.
That apical bud at the very top is a massive flashing green light saying, all traffic, all metabolic energy drives straight up the main highway.
Right.
And the auxin is acting like a fleet of police cars, blocking off all the side streets, keeping those lateral buds totally shut down.
Yes, and the plant does this for a good reason in nature. It ensures it doesn't waste energy growing sideways when it's competing with other plants for sunlight. It prioritizes the vertical sprint to get above the canopy.
But then you come in with pruning shears.
Exactly. When you remove that apical bud, you are removing the entire source of the auxin.
You literally chop off the green light, and you remove the police cars blocking the side streets.
Precisely. Without that steady downward flow of auxin suppressing them, those dormant lateral buds suddenly wake up. And there is another set of hormones at play here too, called cytokinins.
Cytokinins, where do those come from?
They're produced in the roots, and they travel upward, and their job is to promote cell division and side growth.
Oh, interesting.
Normally, the downward auxin completely overpowers the upward cytokinins. But once you snip the tip, the auxin drops, the cytokinins take over, and all those side streets just burst into activity.
The biological traffic jam reroutes perfectly. So instead of one long, heavy stem doomed to collapse under its own water weight, the energy distributes to multiple nodes along the sides.
Exactly. The plant pushes out new stems horizontally, and it becomes much thicker and bushier.
If you've ever bought a perfectly round, bushy plant at a garden center, brought it home, and wondered why it turned into a leggy, sprawling mess a month later, this is why.
Yes. The greenhouse growers were meticulously controlling that apical dominance. And once they stopped pruning, or once you got it home and didn't prune it, the plant just reverted back to its vertical sprint.
That makes so much sense. So by forcing the Mexican mint to distribute its weight across multiple shorter side branches, Aang preemptively solves the physics problem we talked about earlier.
Right. The plant never reaches that critical tipping point where the statoliths have to step in and sense gravity. Yeah. The structural collapse is prevented entirely through this hormonal manipulation.
It's wild. Gardening is often framed as this gentle, passive hobby, just watering and watching things grow.
Yeah, very relaxing.
But Aang is acting as a biochemical engineer here, just aggressively redirecting the flow of hormones to dictate the physical shape of a living thing.
It really is a form of engineering.
And the diary entry doesn't even stop at the pruning. We really have to talk about what happens to all those severed stems, because this moves us from biological hacking straight into environmental engineering.
Well, a seasoned gardener doesn't just throw healthy plant material into the compost bin.
Right.
Those severed stems, which were cut simply to stop the stretch, they are the raw materials for propagation. They represent the entire next generation of the garden.
Right, Ang details the cycle for these cutting, and they aren't just immediately shoved into a fresh pot of soil.
No.
There is a waiting period. Ang allows them to mature in water or some starting medium until their own roots are really well established. But think about the mechanics of what is actually happening there.
It's quite profound when you really look at it.
It is. You take a piece of a stem, a structure that is literally meant to hold leaves and transport water, and you demand that it suddenly become a root system. How does a stem cell know how to become a root cell?
It relies on a biological superpower called cellular totipotence.
Yeah, typitancy.
Yes. In human biology, once a cell specializes, say, it becomes a liver cell or a skin cell. Its fate is pretty much locked in. You can't turn a skin cell into a heart cell naturally.
Right.
But plant cells are incredibly flexible. Many differentiated plant cells actually retain the full genetic blueprints to become any other part of the plant.
Wait, really? So they can essentially just reprogram themselves?
They absolutely can. When you sever a stem, the trauma of the cut, combined with suddenly being isolated from the root system's nutrients, it triggers the cells at the wound site to de-differentiate.
De-differentiate, so they go backward.
Exactly. They revert into a mass of unspecialized cells. This mass is called a callus.
A callus, okay.
Then, taking cues from their new environment like moisture, darkness, and their internal hormone, shifts those unspecialized cells redifferentiate. They read a completely different part of their DNA and transform into root tissue, which is capable of absorbing water rather than just transporting it.
Wow. It's basically localized reincarnation. The stem dies so the root can be born.
That's a very poetic way to look at it, but chemically, yes.
And once those new roots are robust enough, Ang outlines the exact environmental requirements for transplanting them into soil. And here's where I really have to point out a massive contradiction in this entire process.
Oh, let's hear it.
Okay, so Ang specifies that these rooted cuttings must be transplanted into a very specific type of medium, a high drainage potting mix.
Right.
But not just any store-bought mix. Ang explicitly notes that this is a mix harvested straight from the wild.
Ah, I see where you're going with this.
It's crazy. We are spending all this time aggressively hacking the plant's hormones, cutting off its tips, completely forbidding it from growing the way its DNA dictates. All so it conforms to this neat, bushy human ideal.
Yes.
But simultaneously, Ang is trumping out into the woods to harvest the exact, perfectly natural, wild soil the plant would experience in its native habitat. We are forcing it into a completely unnatural shape, but we are pampering it with wild, natural soil.
It does sound deeply paradoxical on the surface, I grant you that.
It's totally contradictory.
But if you look at the mechanics of those fleshy stems we discussed, the contradiction actually resolves itself into a matter of sheer survival.
How so?
Well, a plant with thick, fleshy stems and large leaves is adapted to store water. Very much like a succulent, it holds its hydration internally.
Right, going back to our water balloon analogy.
Exactly. If you take a plant that stores its own water and you place it in heavy, dense potting soil that holds onto moisture and doesn't drain well, you will suffocate the roots.
Because they stay too wet.
Right. Plant roots need oxygen just as much as they need water. In soggy soil, the roots literally drown. Opportunistic fungi move in, and those fleshy stems will just rot right from the bottom up.
Oh, yuck. So the high drainage mixed the wild soil with its natural air pockets and loose structure. It isn't a luxury for the plant.
Not at all.
It's a biological imperative to prevent the plant from rotting in its pot.
Exactly.
Yeah.
You are identifying the absolute non-negotiables for the plant's survival while simultaneously heavily negotiating its physical presentation.
Right.
You artificially reconstruct the ideal elements of its natural environment, the wild soil drainage, so that you have a specimen healthy enough to withstand your artificial constraints, which are the pots and the constant pruning.
It's a really profound compromise when you put it like that. The gardener is basically saying, I will give you the exact wild earth your roots demand to breathe, but in exchange, your canopy has to look exactly the way I want it to look.
That's the deal they strike.
It really makes you appreciate the invisible labor behind just a simple potted plant sitting on a desk. You just look at it and see bushy green leaves. You don't see the wild soil harvested from the woods or the precise hormonal roadblocks set up by the pruning shears.
Or the microscopic starch grains rolling around inside the cells trying to figure out which way is up.
Exactly. But this intensive cultivation, this control, it's just one approach. Eng's diary entry actually becomes particularly reflective toward the end.
Yeah, this.
After detailing this highly controlled, intervention-heavy method of managing the Mexican mint, Eng acknowledges an entirely different philosophy for dealing with this specific plant.
Yes. Up until this point, we have treated gravity and the plant's tendency to stretch as the enemy.
The enemy that must be destroyed. The stretch must be mitigated. The gravity must be fought with scissors.
Right. But Eng notes that instead of fighting the stretch, you can just lean into it.
Oh, I like that.
You can let the plant do exactly what it's trying to do, but you change the environment around it instead of changing the plant.
Eng suggests planting the Mexican mint in a hanging basket.
Precisely. By simply changing the physical context, moving it from a pot on the ground to a basket suspended up in the air, the entire narrative of the plant's biology completely changes. Gravity is no longer the agent of collapse.
Because when the plant is on the ground, hitting that critical length means structural failure. The stems snap or they just bend awkwardly onto the floor.
Yes.
But in a hanging basket, the plant still reaches that exact same weight. Gravity exerts the exact same downward pull, but there is empty space beneath it. The heavy stems are allowed to, as Eng writes, spill over gracefully.
Gravity becomes a design tool rather than an obstacle. The plant's biology hasn't changed at all. It still has the thick stems, the large leaves, the heavy water weight, and the rampant oxen driving it outward.
Right, it's still doing its thing.
But the framework provided by the gardener accommodates that biology rather than fighting it. It transforms what would be a collapsed mess on the floor into this cascading curtain of greenery in the air.
So you aren't hacking its hormones anymore. You aren't setting up roadblocks on its vascular highways. You are just saying, okay, you want to be heavy and fall down. Let's put you somewhere where falling down is exactly what we want you to do.
Exactly.
So what does this all mean? It presents us with two really fundamental philosophies of interacting with the world around us.
If we connect this to the bigger picture, you have cultivation through control, which is the pruning, redirecting, and forcing the wild thing to conform to a tidy human ideal.
The bonsai approach, almost.
Right. And then you have cultivation through accommodation, understanding what the wild thing naturally wants to do and building a structure that allows its tendencies to flourish in a way we can still appreciate.
But, and this is the most revealing part of the diary entry, I think, after laying out this beautiful, graceful alternative of the hanging basket, Eng makes a choice.
Yes.
The post concludes with a really clear decision. Eng writes, "For the time being, I'm opting for the first approach."
The path of control, the path of regular pruning, propagating, manipulating hormones, and enforcing that bushy, compact aesthetic.
It's a very honest admission, isn't it? We really love our neat, tidy, bushy little boundaries. Even when we know there's an easier, perhaps more natural way to let things grow, there is something deeply satisfying about the ritual of pruning.
There really is.
Taking an active hand in shaping the chaos into something manageable.
It speaks to a fundamental human desire to not just passively observe our environment, but to actively participate in it, to leave a deliberate mark.
Yeah.
Eng is actively in dialogue with this Mexican mint, making choices, imposing limits, and guiding its form day by day, entry after entry, all the way up to number 974.
From the very first tip that gets snipped to stop the oxen flow, to the unspecialized calycels forming new roots, all the way to the wild soil brought in to balance the equation. It is a massive amount of hidden architecture.
It is.
Which completely upends our initial comparison from the start of the deep dive, really.
How?
Well, we started by contrasting the rigid control of structural engineering with the messy, rebellious reality of biology.
Ah, yes. The blueprint of a skyscraper versus the sprawling water balloon of the Mexican mint.
Exactly. But what Eng's diary reveals is that gardening isn't the opposite of engineering at all. It is a deeply advanced, highly involved form of biochemical engineering.
That's a great point.
I mean, we explored the gravity-bound physics of those thick stems and the statuses that sense the fall. We unpacked the biological traffic jams caused by removing the apical bud.
We saw the intense environmental engineering required to balance wild soil with heavily manicured shapes.
And finally, we saw the conscious, philosophical choice to impose control over the natural cascade.
The amount of insight hiding inside a routine entry about a potted plant is just remarkable.
It really is.
And it leaves us with an important question that builds perfectly on Eng's meticulous observations. Eng explicitly noted that the plant's natural, unpruned, sprawling habit was less aesthetically appealing. That aesthetic judgment is what justified all the intense intervention, the snipping, and the hormonal redirection.
Right, the natural shape wasn't pretty enough for the windowsill, so out came the scissors.
Exactly. And it forces you to look at the world around you through a slightly different lens.
Mm,
It raises a fascinating question for you to mull over.
yeah.
Think about the plants sitting on your windowsill right now, or the perfectly manicured trees in your local park, or even the broader, heavily structured routines of our everyday lives.
Okay.
How much of what we consider natural beauty or order is actually heavily engineered, pruned, and restricted to fit a very specific human ideal? And what wild, unexpected grace might we uncover if we simply step back, put away the shears, and let things cascade under their own weight?